So let's start our discussion with electric charges by talking about static electricity. And this field is called electrostatics. And basically, electrostatics just mean that the charges are not moving. And to get that to happen, then we just analyze at an instant of time. So as we look at these problems and we see there are forces on these charges, we know that in the next instant of time the system is going to change and everything else would change. But at the moment we're just looking at this at a specific instant of time, and we're going to assume that things aren't going to move while we're looking at them. Now, most people think of charges when we talk about atoms. And although this is not the scientific view of an atom, it kind of gives a picture here. So in the center we have what we call positive charges, and then around the outside we have these negative charges. And these negative charges have some kind of orbit moving around. And this is the classical, this is kind of what everybody thinks about when we talk about charges. But when we're talking about these charges, we consider these charges to be independent. Charges are independent, meaning that they're not bound to an atom. Independent. Sorry. They're not bound to a specific atom, so they could be free by themselves out in space. Now there are two types of charges. We have the negative charge, and this is, we usually relate this to electrons. And we have the positive charge, and we usually think of protons. And the rule is that like charges repel, and opposite charges attract. So if I have a positive charge and a positive charge, I can have let's just put it here. I can have a positive charge and I can have a negative charge, and I can have two negative charges. So in these different configurations, we have like charges, so they're going to repel, and the two negative charges are going to repel, and the positive, negative are going to attract. Now, remember that the forces or directions are along a straight line between the centers of those charges. So we're not going to see any kind of curving going on. We're just going to assume that they're going in a straight line towards each other or away from each other. Now, and as we look at these problems, we have to remember that there is a law of conservation. So the law of conservation of electric charge, kind of like the law of conservation of energy, is that the net amount of electric charge produced in any process is zero. Meaning that if you have a certain amount of charge and some charge goes away, then there's going to have to be more charge made to be able to keep that total net. There can't be any non-zero amount. And the other part of it is that no net electric charge can be created or destroyed. Now, the two terms here that we have to remember, created or destroyed, that's different than saying canceled. And here's what I mean by that. You can't create charge, you can't cause new charges to just spring out of the air, and you can't destroy charges. But what you can do is cancel them out. And so in this case, if the positive and negative charge here that are attracting to each other, if they were to get close enough, then they would cancel each other. And in a sense, because of that canceling, it would seem to reduce the amount of charge. But it doesn't really, because if I take a look at, and I'm just going to do little blips here. Say I have a bunch of positive charges and interspersed inside I have a bunch of negative charges. Then I can make the equation or the rule, and then we use Q for charge. So the quantity of the positive charge minus the quantity of the negative charge will equal some, we'll call it total charge. So it doesn't matter if charges cancel out. It's going to cancel out evenly, one positive to one negative. And so my last look at the total is going to be whether I have more positive or more negative. That's what that Q total is going to be. So even if charges cancel, it's not going to affect this Q total. versus if I had taken and added all the positive charges and then subtracted all the negative charges, I'd still get that same value, Q sub T. So that's the idea of the conservation of electric charge. And we'll be using these ideas through the rest of the chapter and as we start to analyze problems.